In this class, I am explain microtomes. Introduction to microtome. Microtome is an instrument with the help of which sections of tissues are cut, and the process of cutting thin section is known as microtomy. The thickness of sections produced during microtomy may be between fractions of 50 to 100 nanometer. In ultramicrotomy to several hundred microns, these sections are stained using suitable staining techniques followed by observing them under the microtome. Types of microtomes. First one, rotary microtome. The rotary microtome is so called because of rotary action of the hand wheel responsible for the cutting movement. The block holder is mounted on a steel carriage which makes up and down in grooves. This type of instrument is the most ideal for routine and research work. It is excellent for cutting serial sections. Parts of the rotary microtomes: block holder, knife clamp screw, knife clamp, block adjustment thickness gauge, the angle of tilt adjustment, operating handle. Here the feed mechanism is activated by turning a wheel on one side of machine. The knife is fixed with its edge fixed upward, and the object is moved against the knife, rising and falling vertically. One rotation of the operating wheel produces a complete cycle downwards cutting stroke and an upward return stroke, and activation of the advanced mechanism. It is often modified to cut ultra thin sections between 50 angstrom to 200 angstrom. The wheel may be electrically operated or manually. In the former case, the hands may be made free for tissue maintenance. Makes it available for incorporation is automated cryostats. Instrumentation for rotary microtome. The rotary microtome is the most common instrument found in histology laboratory. Although most microtome are manual, some are automatic and semi-automatic, where the advancement of the block and speed of cutting are controlled by a foot pedal or a digital keypad at one's fingertips. Automatic and semi-automatic microtomes greatly improved ergonomics by reducing repetitive stress on joints. Microtomes have become more precise and easier to use since the first version. Although a good microtome can last decades, most laboratories are equipped with modern microtome with current design innovations. Microtomes are very heavy, weighing 40 to 60 pounds. This is reduced vibration during microtomy, in which stability is critical during sectioning to prevent undulations in the paraffin sections. Daily cleaning from paraffin debris and yearly preventive maintenance will keep a microtome cutting optically for many years. The main components of a rotary microtome are described below. Although some microtomes have more bells or visuals, the standard microtome remains relatively simple to operate. Microtome base plate or stage, a platform which has rails that secures the knife holder base. Knife holder base, a part that anchors the knife holder to the microtome stage. The knife holder base can be moved towards or away from the block, but must be stationary and locked during microtomy. Knife holder. This part is comprised of several components including the blade clamp that holds the blade, the knife tilt for adjusting the knife angle, and the face plate that guides that ribbons away from the blade and towards the operator. Cassette clamps or block holder holds the paraffin blocks in place. Typically, the blocks moves up and down with each revolution while the blade is stationary. The block holder may have knobs that allow the user to manipulate the block face in various directions to bring the tissue in alignment with the blade. Corace and wheel moves the block holder either towards the knife or away from the knife. Advancement and wheel turns in one direction and advance the block towards the knife at the specified microns. Most hand wheel are equipped with safety lock to prevent the wheel from releasing and having the block holder come down towards the blade while the block is inserted or removed. The safety lock should be used anytime the microtomist is not actively sectioning paraffin blocks. Micron adjustment. Micron settings for section thickness can range from 1 to 60 microns on most microtomes. Working mechanism of rotary microtome. This instrument is a common microtome design. This device operates with a staged rotary action such that the actual cutting is part of the rotary motion. In a rotary microtome, the knife is typically fixed in a horizontal position. In the figure to the left, the principle of the cut is explained. Through the motion of the sample holder, the sample is cut by the knife position 1 to position 2, at which point the fresh section remains on the knife. At the highest point of the rotary motion, the sample holder is advanced by the same thickness as the section that is to be made, allowing the next section to be made. The flywheel in many microtomes can be operated by hand. This has the advantage that a clean cut can be made as the relatively large mass of the flywheel prevents the sample from being stopped during the sample cut. The flywheel in newer models is often integrated inside the microtome casing. The the typical cut thickness for a rotary microtome is between 1 to 60 mm. For hard materials such as sample embedded in a synthetic resin, this design of microtome can allow good semi-thin sections with a thickness of as low as 0.5 mm. Application. Traditional histology techniques. Tissues are hardened by replacing water with paraffin. The tissue is then cut in the microtome at thickness varying from 2 to 50 mm. From the tissues can be mounted on a microscope slide stained with appropriate aqueous dye after prior removal of paraffin and examined using a light microscope. Advantages of rotary microtome: heavy and stable, ideal for serial sectioning in large numbers. paraffin embedded tissues are cut by a rotary microtome. The knife holder is movable. The sections are cut or flat. It is useful for routine and research papers. Thank you.